Yes. So welcome back, everyone. And we start the afternoon with a demonstration. It's more of a demonstration than a practical by Chris Goddard on the seasonal forecast verification. So this is using one of the Jupyter notebooks that he presented earlier. So yeah, this will write an introduction to producing verification metrics and scores for seasonal forecasts and using data from C3S. So Chris, I'll hand over to you.
Yeah, thank you, Chris, for the introduction. I'll just share my screen again. Yeah, she should now see my screen.
Yeah, you can see it fine.
Yeah, great. Yeah, I think it crops out the part at the top, so you probably can't see the URL, so it's just as it zoomed into the main window.
We can actually still see the URL.
Ah, that's good. Okay, but I will try and remember to paste things in the chat as I go along. Yeah, so as Chris said, this is more of a demonstration than a tutorial, but you can try to follow along if you do already have access to one of these cloud computing services where you can run Jupyter notebooks, or if you already have your own environment set up. But given the time constraints, we won't be able to troubleshoot any issues you might have if you do try to follow along. I've just put in the link to the first notebook we're going to look at, because I think we will have time to look at two. So I suggest rather than trying to run it, at least for this first part, you can simply scroll through the notebook as I'm running through it in the Jupyter Hub. And yeah, this will allow you to follow what we're looking at and potentially find anything in the code that you're not sure about, and then you can ask about it in the chat, and I'm sure my colleague Edu will be available to help answer any questions about this. So a couple of other background things to mention. So yeah, this is the Jupyter book of C3S data tutorials that I mentioned earlier. Here in this first page, you have the links to these different cloud computing platforms, but we also now have these built into the ECMWF CDS Jupyter Hub, which is in beta status. So those notebooks are also all available there. However, for example, for this verification one, we don't actually provide links to these cloud platforms because it uses more resources than they typically provide. And this also holds true for the ECMWF Jupyter Hub, so available via or for the CDS. So this means that if you try to run this notebook there, unless you add some additional constraints such as cutting out a region or reducing the number of ensemble members selected or something like this, then you will run out of resources when you try to run this notebook there. So this is why I suggest for the first part, you just follow along by scrolling through the tutorial. But just to show you what the option looks like if it is there. So if we go to the one on seasonal forecast anomalies, so still in this Jupyter book of examples, you can see we do have these links. And if you click on one of them, for example, to launch in Binder, it will then start launching this Binder environment. You can see here it's already listing all of the .ipynb, so the notebooks below, and eventually this environment will be ready for you to be able to run the notebook interactively. But as I mentioned, this is not recommended for the verification one we're looking at because it requires a bit more resource than is provided there. If you wanted to download any of these and run them on your own machine, you have a download button here in the top bar next to the GitHub symbol, and that allows you to download it either as a PDF or as the interactive Python notebook. And you can also go to the GitHub repository by clicking the GitHub symbol here, and that would also allow you to download the notebook as well as view them in the GitHub repository if that's how you prefer to interact with them. So we are currently going to look at this verification one, which you can see here. So then eventually this will show a preview of the code, and you can download it from there as well. So I'm going to start with the verification notebook in the ECMWF Jupyter Lab environment, which is similar to the one which you will have free access to if you create an ECMWF account and can log into the CDS. You can also log into this Jupyter Lab environment. However, I've logged into one which has more resources available than the than the CDS freely accessible one, just because we want to be able to run through this tutorial without any issues. But for the second notebook I'll run through, I think I will be able to show you that running directly in the CDS Jupyter Hub environment. So I'll quickly go back to the verification page just to remind you what this notebook is trying to do. So I'll put that link in the chat now as well. And I've just noticed the one I put in the chat earlier was actually for the anomalies rather than the verification notebook, but you can toggle between them on the side, on the sidebar of the Jupyter book. So we're going to be looking at reproducing these forecast verification charts, which Edu introduced earlier, where you can select the different forecast systems available that are available from the CDS, both the ones that are currently operational and used in the graphical products, as well as ones which were part of the multi-system in the past, and their data is still available in the CDS. So this is where here you can select the start date you're interested in, the aggregation, so 1 month or 3 month, as well as the lead time, the variable, the score, so correlation, RPS or ROC, and the category that applies to it in the case of ROC, because that's scoring binary events, so whether each tercile is correctly predicted or not, whereas for RPS, that's a continuous score across the 3 tercile categories, so you don't have that option. So I'll go back to the notebook now and we can get started. So the first thing that's required here is to set up the environment, which means that you need to be able to interact programmatically with the CDS API. So there is documentation available on the CDS on how to do this. So I'll now also paste that link in the chat. And if you log in, essentially, so I'm not logged in here to avoid sharing my my own credentials, but if you are logged in, then here where it says key personal access token, you would see your own CDS API key once you've registered for an account and being able to log in. So once you've done that, you can then either copy those details directly into the notebook here, where you have CDS API key equals none, CDS API URL equals none. You could copy those 2 things in, and this would allow you to run the CDS downloads using your credentials. You would then, when you're logged into the CDS, as Edu showed earlier, where you can make requests and see your requests, any request you make via the API will also show up in the user interface. So you'll see any requests you've made in the CDS. Another option is that you can set up, which is what I've done here, you can set up a CDS API RC file, so essentially a settings file, which is in your home directory, and then that will be used without you needing to paste your credentials into the notebook directly. I've just realized this may be a little small. I'm not sure if zooming in is going to help. Yes, it does. Good. So hopefully that's now a little easier for you to see as well. Look, I can also close this sidebar at the moment. So then we have a section in this verification notebook where we need to import some libraries which are going to be used to produce the scores, to read the data, and manipulate various things like the time dimensions of the data. So we have a set of imports here. One of the positives of running in one of the cloud environments is that often the environment will already be set up for you. So you don't need to download all of these packages onto your own machine. And that is also the case for the CDS Jupyter Hub, where it has some pre-configured environments, but occasionally you will need to install something additional, such as this pip install here for X skill score, which is a package for computing skill scores. So after we've set everything up here, we then need to specify a directory in which to save the data. Note again that depending on the cloud platform you're using, you may need to configure this differently so that you're saving in the right place. For example, in the CDS Jupyter Hub, you have a Scratch directory because the home directory is limited to only a gigabyte of storage. So you would need to change this to save in the Scratch directory. So I'll keep moving through. And as I mentioned earlier, please put any questions in the chat as they come up. So now we're going to formulate a data request for the CDS API. So actually, the first, if you're not familiar with the data, the best thing to do is to actually go to start with the download form itself. So actually in the CDS user interface, which I've just switched to. So here we can make some selections. So here we're looking at seasonal forecast monthly statistics on single levels. We select ECMWF, we select one of the systems, so the most recent one, so system 51. We can then choose a variable or multiple variables. In this case, I'll select 2 meter temperature. You have some options about the product type. I've just clicked ensemble mean here, but you probably would want the individual members to choose how to create products from that yourself. And then you can select year, month, and lead time. As Edu mentioned earlier, yeah, this depends on the product we're looking at. If we're looking at these ensemble mean products, these are only available for the forecast periods rather than the hindcast periods, whereas if I select monthly mean, then we now have unlocked all of these options, including the hindcast. There was a question earlier about computing regional averages. So that isn't actually something you need to do yourselves. You can actually just, well, you still would need to compute the average yourself, but at least the CDS gives you the option to extract a subdomain already. So you don't necessarily need to download the whole global field. You can select a subdomain and download the data for that subdomain directly. And as Edu also showed earlier, here you can actually see the details of the API request filling out underneath. So you can see that we do have this area keyword here we could use if we wanted to select and request a subdomain. I'll go back to the notebook now and just scroll through this initial setup. So here I am requesting the common hindcast period that Edu and Anka introduced, which is 93 to 2016. Start month 6, so June, the forecast that's just occurred, but here we're looking at the hindcasts of that corresponding to that forecast. And then we set up some directories to save our scores and plots in. Here we have a couple of drop-down boxes which shows the data that's being requested. So yeah, here this is showing you that we're defining what is essentially the parameters we're defining in that API request. So this is actually the previous CMCC system. And you can see here the details of what we're requesting. And of course, the month here, the start month and the lead time months, and the years, the hindcast period, these are all things which you can vary yourselves, depending on your use case, as well as the variable, of course. Here we're doing verifications. We also need a reference. In this case, we're using ERA 5 data, although Franco has already discussed earlier why you may not always want to just use reanalysis, and there may be arguments for using different products for different regions and different variables. Yeah, so just scrolling down here, there's a warning to remember to accept the terms and conditions in the CDS, otherwise the API also won't allow you to request data until you've done that. And then we can download some data. I will actually run, I think, one of these requests just to show you what that looks like. Let's run these configurations, but I won't run the hindcast request because yeah, that will take a while. So here I'm just going to request the ERA 5 data. which we need to line up with that hindcast data to produce our verification scores. So I'll press run on that cell, and you'll see that the CDS request was sent, it's been accepted, and in a moment it should start running and download the data. Just waiting for that. While we do, we can, there we go, that happened very quickly. So it has now downloaded that data in the data directory, which I defined earlier. So now we can look at computing. So we have our forecasts and hindcasts, and now we can look at computing deterministic and probabilistic products from the hindcast data. And then we can score those products. There's something here about lagged versus start systems. Lagged start versus burst mode systems. I won't go into that in detail, as I mentioned it earlier, but just to note that that's important when you're reading in the data from the file, because it changes some of the metadata to do with the time dimensions. And then we have a large cell here, which is going to open up the hindcast data. It's also important, especially when you're using one of these cloud computing platforms, to think about chunking your data. So this is a function of xarray and dask, which allows you to read the data into chunks, which can allow things to be parallelized and essentially avoid reading the whole array into memory at once. So this can be important to play around with depending on the resources you have available. I won't run through this in detail, but here we're essentially computing the 3 monthly aggregations corresponding to the underlying monthly data, and then producing anomalies for both the monthly data and the 3 monthly data, and producing anomalies using the ensemble means from the hindcast period. I won't run that cell because we'll be waiting a while for that. Another thing you can play around with on these when you're trying to work with limited resources is actually forcing Xarray to delete some of the arrays you've already used from the system memory. It should be doing a good job of cleaning up these kind of things in the background anyway, but just to mention that is something we can also force it to do. And here now I'm printing the hindcast and forecast arrays. We can have a look at how they look. So you can see we have our ensemble members, dimension, forecast month, which is our lead time ahead in time in the forecast, or hindcast in this case, and then the 24 start dates in the hindcast period, and our global latitude and longitude. We also have a 3 monthly version of that as well. So next we define a function which will need to compute the probabilities for the tensile categories. Again, I won't have time now to go into that in too much detail, but here we now have a cell to compute probabilities for the tensile categories, and we define the quantiles that we want to look at. So here you could, to reproduce other graphical products, such as the 20th or 10th percentile or other thresholds, you could change this here or add additional quantiles in here. So after running that, we've then computed the tercile probabilities and saved them. So as this notebook runs through, it saves everything to avoid things needing to be recomputed at the end. So now we've computed the products, so the deterministic anomalies and ensemble mean anomalies, as well as the tercile probabilities. We can then compute scores. So we can compare those products to the ERA 5 data that we downloaded and compute scores. So one of the tricky things we need to deal with here is lining up the observations with the seasonal forecast data, because of course the observations only have, or in this case reanalysis, only has one time dimension, Whereas for the seasonal forecasts, we have each start date and month, but we then also have the lead time. So this cell is about reading in the ERA 5 data and reformulating it so that it aligns in time, in the time dimensions with the seasonal forecast data to ease that computation of the verification metrics. Yeah, I've already run these cells, so I won't run them again, although I will run the plotting at the end, so we can change some of the options here. The other thing I should have mentioned earlier is actually that here in this example, I have changed a couple of things compared to the HTML version of the notebook that you have to scroll through. So instead of selecting this older CMCC system, the previous version of the CMCC system, here I've selected the newest system from Métier France. So I've changed the origin here and provided some new details for plotting that. And I also have changed the start month requested from March to June. Okay, so I'll scroll back through to the computation. Yeah, so these cells will take a while to run if you're doing it yourself, which is why I'm not running them again here. And now we can compute our scores. So for the deterministic scores, we're essentially looping through and doing correlations between the seasonal forecast for a given start and lead time and the observations, which then line up, which are manipulated to line up with that. We then concatenate them and have an array of correlations and corresponding p-values. Save those to disk. We then do something similar for the probabilistic scores, but there we need to use, of course, different metrics. And here it's the RPS and ROC scores that are computed. Again, I won't go into these cells in detail, but this is available in the notebook for you to look at in your own time. So now, once we've done this, we can plot these outputs. So here we select whether we're looking at the 1 month or 3 month aggregations, and also the forecast month we want to plot. So in this case, I've changed it to 2. So we'll be plotting the verification of the July forecast from a June start. We also have some options for different variable names if you've downloaded some different variables. And the category names for those tercile, the terciles that we defined earlier. And again, you can vary this depending on what thresholds you've defined. Click run on this. Here we just produce some strings essentially to decorate the plots with the information that you see at the top of the plots in the verification page. So if I go to here, you can see we have this information in the title of the plot. And through this, and now we will produce the correlation plot. So yeah, you can see here that compared to the HTML version, this is updated with Métier France System 9, and we're looking at the July forecast from June. And we can actually directly compare this to check it's equivalent to what we have in the verification page. So we can go to System 9, June, start, so lead month 1, and that will correspond to July. We're looking at humidity temperature, but at the moment we're looking at correlation. And I'll just switch between them a couple of times, but hopefully you can convince yourselves that those are indeed equivalent plots. We've reproduced the deterministic score, so the correlation, and we can now look at the probabilistic scores as well. So we've computed the ranked probability score in this notebook. So we can plot that. Let's go ahead and do that. So this, this is a score for the tercile categories. in combination. We have some documentation on the different scores above. It essentially links to the WMO definitions of these different scores. And we also can look at the area under the ROC curve for each of the categories individually. So I'll run that as well. So it's now also produced these three plots. So this was the first notebook I wanted to very quickly run through. And of course, you could now customize this to be run for multiple systems. And you could also even define your own multi-system products for combinations of those systems, and then verify those products with the same kind of workflow. I also want to mention that we are planning to produce a notebook on our multi-system combinations. So this would allow you to even more easily define a multi-system product, customize it as you wish, and then verify it. For now, we do have documentation on our products. So I'll just change to that now and put that link in the chat. So in this page, it may not be perfect, but here we do define how we produce the different products. So we have a section on the data products, which Edu was introducing earlier. And we also have a section on the graphical products, which he introduced. And that includes a description of how we produce our multi-model combination in both the case of ensemble mean anomaly, as well as probabilistic products. So for now, this would be the place to go to understand how we compute those products. But we will soon, in terms of the multi-model aspect, multi-system aspect, but we will soon have an example on how to do that in our Jupyter book of seasonal C3S seasonal examples. So I've still got a bit of time left. So this is where I'm going to try something a bit more risky and close down this ECMWF internal Jupyter hub and open up the CDS one. Which is something you would also be able to do yourselves. I'll just go to the hub control panel and stop this server. I'm going to paste a link to the documentation while it's closing. So this is documentation about this beta data store service Jupyter hub, which is something that everyone who has access to the CDS would also be able to access. But as it explains here, this is currently an experimental service and is subject to change and may be more unstable due to that. So it should not be used operationally at the moment. If I go back to my Jupyter hub. So if you've logged into your an ECMWF account and you go to this Jupyter hub link, which is linked from the documentation, but I'll also pop the link in the chat as well. This is where you would start your CDS Jupyter Hub session. So here I have more options because I'm internal staff, but the option you'd be presented with is this ECMWF data store service option. And you can see here that this is quite a limited service. So it has only 4 GB of RAM and 2 CPUs. The session will last to a maximum of 5 hours. In your home directory, so what it calls private storage here, you would only have 1 GB of memory. So of course, this should not really be used for saving any data, but it's more for any configuration files, environments that you need to use, and then some scratch storage, so 100 GB, which is where you should save your data to. So I'll try starting a session. Let's try again. I think I've had that happen before, where sometimes it doesn't find a free session. I'll do it one more time, and if not, we can switch back to the internal one. If there's a few of you trying to access this at once, perhaps that's the limiting factor. Let's see. Okay, this looks more promising. So I think it has now found an empty server to start my session on. Yes, so I'm now in this. So this is the ECMWF CDS Jupyter Hub environment, which you are also able to access. So the first thing I want to show you is that here on the left, you now have access directly to these notebooks, which are in the C3S Training Jupyter book, which I mentioned earlier. So if I open up this, you can see we have them here organized by different data types. And if I go into seasonal forecasts, we have this seasonal forecast verification notebook we've run through. If you do open one of these, you'll note that because we're looking at it in a common directory, it's read-only. So if you wanted to modify anything, you'd need to create a copy of the notebook in a different folder and make any changes you want to. And so what I wanted to show you here, though, was using one of the other notebooks, so outside of the training repository. So if you go to our C3S Jupyter book on additional examples and workflows. I'll post again this link in the chat. Then you can see if we look here under workflows related to graphical products, we have a few different notebooks there at the moment in draft status. We have 3, and one of those is reproducing the single system graphical products for additional variables. So this essentially aims to make the code behind the graphical products available and also allow users to create products for which we don't currently plot the graphical products. So as Anka and Edu both mentioned, we only produce graphical products for a limited list of variables compared to the whole list available from the CDS. So using this notebook, you'd be able to reproduce the graphical products using, as you wish, for different variables and different ways of aggregating the ensemble members, for example, or producing probabilistic products as you see fit. So I'll now switch back to the Jupyter Hub. We can close down this sidebar, and actually, no, I do need the sidebar because I want to open up that notebook. So to open up an external notebook yourself here, what you would need to do is go to the Jupyter book or GitHub page of the Jupyter book that you wish to download a notebook from. Again, click on this download icon in the top right, choose .ipynb. That will download the notebook, and you can then drag and drop it directly into the folder structure here on the left in the Jupyter Hub. So I've already done that. So I now have this Jupyter notebook on reproducing the single system graphical products within the Jupyter Lab environment. You'll notice that some things don't render perfectly from the notebook, and that's because they're there for the HTML Jupyter book. So things like the logo or these note boxes don't look exactly as they do in the online Jupyter book. Sorry, in the HTML Jupyter book online. And what we can do is quickly run through this example as well. So like last time, I have some configuration where I'm importing packages that are required and defining the CDS API client. Again, if you don't have a CDS settings file set up in your home directory, as explained in the documentation, then you can directly copy and paste your URL and key in here. I'll run through these cells quite quickly. Here we have a cell which defines all of the different systems. This is actually slightly out of date now, and some of these systems have been updated since we produced this example. So we'll be updating this soon so we can run through. And here we're defining some variables to request. So we're defining defining t-mean, which is one of the variables which we do create graphical products for, and we're also defining the daily maximum temperature and minimum temperature, which we might want to compare to the daily mean to see if we are interested in products which look at those variables as well as the mean. So again, I have here a cell which is defining things to put into the CDS API request. So I'm choosing out of that library or dictionary object here I have above, I'm choosing ECMWF, System 51, and forecast year 2024 and February stat month. I'm just choosing tmin from those variables I listed above, and then the common hindcast period as before. So that's now defined. I've made a directory in which to save the data. So here I've used the Scratch directory in the ECMWF Jupyter Hub, which is something you need to do to avoid filling the home directory. I'll move into the API requests. So I think because I recently run both of these, they should be relatively fast. So I'll click run on both of these. So now in the background, these requests have been sent to the CDS. This one's been accepted. I will then start running and download the data. Actually see that by looking into the folder structure on the side here. We can go to the Scratch directory and you can keep track of the progress in terms of the data downloads there as well. So those are now running, and I can start moving to, we've downloaded both of those. So here we've requested the hindcast data as well as the forecast data. So to produce our graphical products, of course, we need both of those to produce the anomalies and to produce the probabilistic products. We also need to know about the hindcast climatology. So we request both the forecast and the hindcast data. We can then load both of these into memory, again using chunking. Here you can see a graphical representation of the chunks. So we have chunks in the forecast month dimension as well as in the longitude. And this helps when performing some operations. It allows the data to be, chunks of it to be loaded into memory instead of the whole file. So we do the same for the forecasts. Of course, our forecast file is much smaller, so we don't worry as much about chunking it. And now define a valid time dimension. Here we have a section about defining, selecting qualifying ensemble members. This is important for the lagged stat systems, and we have a page in the documentation which describes this. And it's also described in this product descriptions page, which I mentioned here. So now we're again defining in some quantiles to produce the tercile summary and computing the forecast probabilities of those terciles. So now you can see, we have an array now with only forecast month and lat and long, and this is our probability tercile summary, which combines the probabilities of below normal conditions, above normal conditions, and normal conditions, and this is what we have in our graphical products. And we can now plot that, which will help that become clearer. It's taking a little time to plot that. And another thing to mention here is that it will look a bit different to our graphical products because those are filled contour plots rather than gridded mesh plots, which this notebook produces. Okay, that seems to be taking a while to run, so we can instead look at it in the HTML version of the book. So we can skip through to the plotting tercile summary section. So here we plot that tercile summary for each lead month. So here the yellow to red colors correspond to probabilities of enhanced probabilities of above normal conditions, and blue colors enhanced probabilities of below normal conditions, and in white this is either forecast for the middle tercile or the 30 to 40% boundary for above or below normal. And here we've done this for daily minimum temperature rather than daily mean temperature, which is in our graphical product. I'll now skip back to the notebook to see if that has run. Yes, it has. So we now have these in the Jupyter Hub. So we have a plot for each month. And if we compared these to the plots available in our seasonal charts, I don't think I have that open. Yes, I do. Here we go. Then you'd find, other than the visual differences due to the filled contours, you'd find that the plots are very similar. We also have a section on producing the ensemble mean anomaly. Of course, that's quite trivial, but what we also do in our plots is do some significance testing. So we do have a section on that as well. So first we make a basic plot without the significance testing, and then we have a section where we do that significance testing. I won't run the cell that has run actually. I was going to say I think it might take too long if it will take too long I think if I run this significance testing cell, but it's a Mann-Whitney U-test, and that allows us to plot these green contours you can see on the plot here, which shows areas of significance in terms of the forecast anomalies. Yeah, so I'm sorry that session wasn't a bit more interactive, but hopefully it's given you a bit of an idea about the Jupyter notebooks we make available, and also how you can run them in the ECMWF Jupyter Hub directly using the CDS resources, or on some other cloud platforms which are linked directly from the training notebooks. So I think I'll hand over back to you, Chris, and happy to answer any questions, but since that was quite a lot of detail, probably we're also happy to answer questions via the user forum or any other mechanism for getting in touch with us.
Great, thanks a lot, Chris. That was brilliant. And yeah, if that was probably a bit too fast, but to kind of follow along in a more interactive way, but you can look at these in your own time and kind of explore them and kind of get into the nitty-gritty. Try running them through the cloud platforms or even in your own system. I don't see any questions in the chat, but and also I don't see any hands up. You just go through all the different participants. I don't see any hands up. There's a hands up from Anka.
There was a comment in the chat, which I think it's worth voicing. Eduardo posted it a few steps up about the situation where people want to run a limited area rather than a global field. So I don't know if you want to repeat it, Chris.
Yeah. Goddard. Chris Goddard,
or whichever Chris it's.
So it's just do you want to do it, Chris?
So as I do mentioned, I think I showed it when I was showing the CDS form. So the CDS form allows you to extract a subregion. If you do that in the form, it will show you the syntax for doing that in the API. I think I still have that open here. So here you have this area keyword, and this would then allow you to make, in those notebooks I've just shown, you could copy this in, choose the region that you're interested in, and this of course would far reduce the amount of resources required to load that into memory and compute the scores or the verification. So the verification of the product. So that is definitely something to consider doing if you don't need global fields.
Okay. I don't think there are any other questions.